Starting with a bit of motivation or background. Yeah, blah, blah, blah. You know this, right? IoT is everywhere. Incidents are obvious with IoT because they come without mostly or no security in place, right? Default passwords and so on. So this is very attractive for attackers, exactly right, because it's a strong opportunity as IoT becomes widespread in all the sectors. It's a great opportunity to, well, grab some money, right? So, but this started some years ago, but it's still, it's not only still a reality, but it's still increasing. So we see that, for instance, based on the report from this year, there has been in the first 2 months of this year, there has been around an increase of around 40% in the average number of weekly attacks per organization, specifically targeting IoT. Okay, so equally and very interestingly, and this is just an additional information, this is more observed in European organizations. So again, focusing only in attacks targeting IoT. So overall, we can affirm without any doubt that IoT systems require and depend on security, and for security also trust in the associated entities, and particularly devices, right? So for this, as touching also the previous training session, techniques and technologies for assessing this trust are required. And one such technique is that of remote attestation. Remote attestation, referring to IETF-RAT terminology, determines whether relying parties can establish a level of confidence in the trustworthiness of remote peers. So essentially, it is a way to prove whether a computer or a system is trustworthy or not. So there are lots of well-known solutions, such as TCG, TPMs, FIDO attestation, among as well as smartphone-specific ones, such as this Android key store attestation, which meanwhile has become deprecated, as far as I know. Anyway, as you see, these solutions were targeted to non-IoT systems, right? So you see, everyone has a laptop with the TPM, especially if it's a Windows machine or Mac, you know. So moving on to other important concepts regarding remote attestation. So there are two, simplifying, there are two main stages, right? We have the evidence appraisal, where proofs or evidence are sent by the attester, and this evidence is analyzed by a verifier entity, and it's appraised according to its policies. So these policies can differ significantly. The second stage, which regards the processing of these, the attestation results generated by the verifier during the first stage, and relates to the analysis of these attestation results by the relying party, according again to policies, ultimately leading to trust decisions. So, for instance, the ultimate decision may be to authorize a given device to access a given service or a given network. With respect to the key entities involved in these procedures, we have three main ones. The attester, as you might already understood, it's the entity which is being attested or verified with respect to its trustworthiness. It's entity whose evidence will be appraised in order to infer the extent to which the attester is considered trustworthy, in other terms. So the verifier is the entity which appraises the validity of such evidence about the attester. and again produces the attestation results to be used by a rely party, which is the ultimate consumer and interested in this remote attestation procedure. Again, which is the entity that depends on the validity of information about an attester. So with respect to the main entities, again, simplifying a bit, there are the other ones which are also relevant, but we need to filter out some information. So we have the claims, which each claim is a piece of information which makes up the evidence. So evidence is a set of different claims. For instance, claim A can be configuration parameter X, claim B can be the measurement from the state of a given firmware, and so on. So again, the evidence is a set of claims, and it's generated in a way the verifier can consume the information. The reference values are important because they are the baseline. So they represent the set of values against which the claims will be compared against as part of applying the appraisal policy of evidence. So there are three main interaction models. With each of these also have some sub-modes. The first one being the challenge response. The challenge response remote attestation is characterized by being initiated by the verifier through the sending of a remote attestation to the attester. So this request is the challenge and includes, among other possible attributes, handle. So the handle can be, for instance, a nonce, which can uniquely identify the request, and it's used to avoid replay attacks, for instance. Another important aspect is the claim selection, which is what are exactly the claims that the attester should be sending among the ones he can actually collect and send. So two different reference models are proposed in a challenge response mode. The first one, and comparing with the real life scenarios which originate the names for these modes. The first one is a passport model. So for instance, as a citizen, I'm the attester. I provide my biometrics as evidence to the government. The government, acting as the verifier, generates the attestation result, which could be the citizen card. And this citizen card is the attestation result I present to any relying party which requires it as attestation result, right? The second mode is the background check model, and the difference is the way that, okay, in this case, the attester sends the evidence to the relying party, which then forwards it to the verifier for appraisal before receiving the attestation result. So doing again an analogy, in this case, the attester would be me as someone applying, for instance, to a job. The relying party is the new company, and the company will confront my previous employees and education universities, which, acting as the verifiers, would confirm, okay, this is correct, and he actually has the information which is stated in this V. Moving to the second main interaction model, unidirectional. So in this case, both the attester and the verifier can initiate the process. So this is a key difference. In the verifier one is similar to the challenge response, while the attester initiated mode is characterized by having the attester collecting only the claims that have changed since the last attestation procedure. Finally, the third and last mode is the streaming mode, remote attestation, and it essentially entails establishing a subscription state in order to enable continuous remote attestation. So there are again two subclasses or two options. The one without involving a broker, where the verifier subscribes directly to an attestor's evidence in order to be set directly to it, while in the option where a broker is involved, the attestor publishes the evidence to one or more verifiers using the broker. In any or in both cases, the attester the evidence whenever it changes, similarly to the unidirectional mode. So finally, to conclude the concepts part, it is critical, or it is significantly important to refer to the root of trust, right? Root of trust is the, well, let's not use my words, but according to TCG, it can be defined as a component that performs one or more security-specific functions, such as measurement, storage, reporting, or verification, among others, and it is trusted to always to behave in the expected manner because its misbehavior cannot be detected under normal operation. So a good and a very well-known example of a root of trust is that of the TPM, where, for instance, we have the PCR values representing the readings or measurements and so on. So there are three main classes of roots of trust. Trying to organize this. The first one being the hardware-based of trust, which is based on hardware, such as a chip. And given that it's hardware-based, provides the most security guarantees. But on the other hand, it's limited in terms of flexibility, right? In order to employ such root of trust, you really require to have the chip which enables it, right? There is also the other extreme, which is a purely software-based root of trust. And in this case, we have a lower level of securities. It's easier for attackers to overcome the remote attestation. But on the other hand, you also have a higher level of flexibility. You are not delimited to a specific hardware. And then we have the hybrid root of trust, which is essentially is a hybrid approach where you pick up the advantages of each, not only the advantages, but the cons of each of the two other approaches. And a good example of trusted execution environments. So I will now pass the ball to which will present the solution we devised in Arcadian.
Thank you, Serge. So I'm now going to show the current state of our solution, which we call RA2IoT. So the main goal of RA2IoT is to provide a service to main target stakeholders, such as IoT service providers and enterprises, a service that allows them to verify if their services or devices are running as expected. Our solution has the following key features. So it must be device agnostic, so that you can provide support a wide range of services. The only assumption that we make is that the device must have an eSIM or a SIM card as a hardware root of trust to sign payloads. It supports attribute-based encryption using the eSIM as a root of trust to sign the evidence. It follows a challenge response model with support for attestation queues, so that other components, such as the reputation system, can trigger the attestation process, can queue the verifier to trigger the attestation process, and is integrated with reputation system, which we use as a reliant party, so that the attestation results contribute to the modeling of the trust of IoT devices or services. So, since we only consider eSIM or SIM card as an hardware of trust, there's no way to make sure that the the measurements reported by the device are trustworthy. So an alternative approach is to use a software-based root of trust. However, most software-based remote attestation schemes rely on assumptions that are not realistic for most IoT devices, such as heavy memory requirements, have strict time limits for when the attestation must happen, and also computational requirements. So the main challenge that we need still to solve is how to design a software-based root of trust for the measurements such that it is device agnostic, requiring as little reference information as possible. It's lightweight on the device, so possibly switching the heavy computations to the verifier, and is able to assess the device state based only on partial data, because since if the verifier is the one that does the most part of computations, it cannot have a continuous access to the state of the device. So this is an high-level view of our architecture. So the two main components is the verifier and the attester. Both of them use an external library provided by one of our partners, which is the ARM encryption library, to perform cryptographic procedures. Also, the verifier sends attestation results to and receives attestation used from a relying party, which in the context of this project is the reputation system. So to use our solution, the service providers must integrate the attester on their services, on their devices or apps. Currently, we support two types of platforms on Linux-based devices. The attester is provided as an executable or on Android smartphones. The attester is provided as a library, which is to be included on the app. And additionally, there's another Android library that we use to be able to collect the data, the claims from the device. Although currently this is a temporary measure that might change in the future. So now I'm going to present a small demo, but first some important considerations. So the claims and evidence that we present are collected from the device, but are just for demonstration purposes. Also, the reference values, which are not seen in the demo, but are used, are defined, but in the real scenario, these come from sources such as the reference value providers, which could be service providers. Also, we are running the tester just on a Linux Docker container. And one thing to make clear is that the bootstrapping only happens once and not for every attestation process. Okay, so this is an high-level first of the remote attestation process. So the process begins when the verifier creates the attestation request, which then sends to the attester that processes the attestation request and generates the evidence. This creates the attestation response, which is sent back to the verifier. The verifier, in turn, processes the response. If everything goes well, it appraises the evidence, generates the attestation results, and reports the attestation results to the reputation system. So this is the bootstrapping part process. Both attester and verifier begin by requesting keys from the ARM encryption authorities using the provided external library developed by one of our partners. In the case, after this step, in the case of the attester, it is ready to receive attestation requests. So the process starts. As I said, creates the attestation request. It does so by first generating a nonce and the claim selection, which are highlighted in this image. This is sent to the attester, which then, of course, receives it. Here again, we have nonce and the claim selections sent by the highlighted, proceeds to process this request. So it does so by generating the evidence. This is done by collecting the claims requested on the claim selection that came from the request and copying the nonce that verifier sent to the response. Both nonce and claims are then encrypted together and included in the attestation response, which is then sent back to the verifier. The verifier, in turn, receives the attestation response, decrypts the evidence. Again, is the nonce and now the claims reported. The next step is to verify if the nonce is the same as one that it sent on the attestation request. If that's valid, it proceeds to the appraising of the claims according with the reference values that he has and its associated policies. Finally, it creates the attestation result, which right now is a proportion, the evidence appraisal result, which is a proportion of the valid claims according with the policies, and an utility level, which this is just for now a placeholder, which is for free work. And finally, it sends the results back to the reputation system to influence the trust on the device or service. And that's all. Thank you.